Hello viewers, you are highly welcome to my YouTube channel. So into this tutorial we are going to continue from where we stopped. So today we are going to be looking at the commutative property. So that is commutative property of what? Of binary operation. So we are going to be looking at the commutative property. So what do we understand by commutative property in binary operation? So now let me give you this definition before we move on. Now let's look at this definition. So a binary operation star is commutative on a set of real numbers if a asterisk b equals to b asterisk a for all a comma b belong to set of real numbers. So what we are trying to say here is that before you can say a or b is commutative, okay, that is under this operation. So now before you can say a binary operation is commutative on a set of these real numbers, okay, so this condition must be satisfied, that is a asterisk b must be equals to b asterisk a. So now, you know, in the basic operations we have additions, we have subtraction, we have multiplication, we have division. So now we are going to be using this, which operation is actually what is actually commutative when we are talking about these basic operations I mentioned earlier, like addition. So we are going to look at the addition, okay. Is addition commutative? Okay, is addition commutative? So now if you want to know that whether addition is commutative, what we are going to do now is that we are going to pick any number that is from the set of real numbers. So now when it's a set of real numbers, that's where we have what? Anything like 1, 2, 3, 1 over 5 over 7 and so on, like that. Are you getting now? So now this real number comprises of what? Of rational numbers and irrational numbers. Are you getting it? So now we have addition. We want to know whether this operation addition is commutative, okay. So now if you want to know this, so now we are going to pick a number that is from the set of real numbers. Let's say like 2 belongs to set of real number, right? So now this 2 is belong to set of real numbers, and also 3 is also belong to set of real numbers. Are you getting it now? So now if you now want to use addition, are you getting now? If you pick these 2 and add it to 3, are you getting now? We consider we are going to have 5. Or you pick 5 first, we pick what? We pick 3 first because 2 is coming first here. We put 3 first, then add it to 2. We consider that we are going to have what? We are going to have 5. So now what we are trying to say here under this commutative, this addition is commutative here. Do you understand now? Operation addition is commutative on this set of this number we are given. So when you look at 2, we pick 2 from the set of real number, 3 is from the set of real number. Are you getting it now? So now I had 2 to 3, we have 5. I have 2 to 3 also, here we have 5. Are you getting now? But look at this. This is 2 is coming first, and what? And b comes after. Then here 3 is coming first and 2 comes after. But when you look at their result, you can see that we have the same thing. So that is what we mean by commutative property. So therefore, operation addition is what is said to be commutative. Are you getting it now? So now let's look at the multiplication. Okay, now using these numbers, you know, the members of the set of real numbers, that is 2 and 3, if we have 2 multiplied by 3 is equals to 6, or let's say 3 multiplied by 2 equals to 6, you can see that this is multiplication. So when you combine these 2 and 3 with this multiplication, so we are going to have 6, but 2 is coming first, then 3 is coming after. We have 3 coming first here and 2 is coming after. We can see that we have the same result to be, this is 6 and this is also what? 6. Therefore we can conclude that addition and multiplications are commutative under the what? Under the set of real numbers. You know, when you combine 2 or more numbers together with the addition, so we are going to have with their arrangement, you can see, don't forget that A as there is B, so 2 is our A here, B is our 3. Okay, B is now 3, then A becomes 2. So that is what we are going to do. Now let's look at subtraction. Is subtraction commutative? Okay, we are still going to be using these numbers. Okay, this number we use there, we are still going to be using them. So now we have 2 times 3 equals to 6. Okay, we want to use as well the subtraction. Now the subtraction, let's say we have 2 minus 3. 2 minus 3 is going to give us what? Is consider this one is going to give us minus 1, or let's say 3 minus 2. So 3 minus 2 is going to give us what? Is going to give us 1. You can see that this result here is minus 1. The result of this one is 1. Are they the same? No. So therefore, we now conclude that subtraction is not what? Is not commutative, because if this happen, so we will not have what? We will not have the same results. Are you getting it now? Let's look at division. So now to look at this division, we are still using the same number. We have 2 divided by what? 2 divided by 3. Okay. So 2 divided by 3 is going to give us what? When we have 2 divided by 3, let's say this is 2 over 3. Is that? Now let's say 3 divided by 2. You can see that this one is going to be 3 over 2. Now when you look at this, this is 2 over 3 and this is 3 over 2. So with the look of things, you can see that this can never be this, because 2 over 3 is not equals to 3 over 2, and also minus 1 is not equals to 1. Okay, so therefore we can conclude that division and subtractions are not commutative. Okay, while addition and multiplication, they are commutative. Okay, so now in the next video, so we are going to be talking or solving more examples on this commutative property. So, and that is going to be the end of the today's tutorial. If you find the class very interesting, do not hesitate to hit on the subscribe button, hit on the bell icon, so that you'll be notified anytime we upload a new content. Also, you can get to us on our Facebook page, Shitu Mathematics Class. Thank you for watching. Bye.